My name is Roberto Quiroz. I lead the team on crop systems intensification and climate change at the International Potato Center. In this program, we're developing the agricultural remote sensing information system for the benefit of small farmers. Remote sensing is a catchy phrase that is used by many people. The easiest way of explaining remote sensing is to explain what we do when we see something. Remote sensing is a process where you have a sensor. This sensor could be a camera that is mounted on a tripod or on a small plane or a satellite. And then this camera would register images, and then you process that. And when you process the image, and based on your experience, you can tell, if this is a crop or this is a building, or if the crop is under stress. And if you have even more knowledge, you can even pinpoint what the stress source would be, if it is a drought or if it is a pest that is affecting the plant. We often use imageries that are taken by satellites, and those products are expensive. If you want to purchase that, those imageries will cost $10,000 to $15,000 per scene that will cover around 60 kilometers by 60 kilometers. Governments don't have the funding enough to purchase those images, or people don't have the capacity to process them. The other conditions to have a good image is that you would have the sky that is clear, no clouds in it. But oftentimes, especially during the cropping season, when especially in smallholder agriculture, where they rely on rains for producing their food, this is not possible. So there are other factors, in addition to the cost, that you need to overcome if you want to have good imagery. Unmanned aerial vehicles, also known as UAVs or drones, are nowadays constantly in the news. Drones are handy platforms of low cost that can be used to fly sensors. The prices are coming down, and nowadays you can get the parts and assemble them yourself. Our mission is to develop drones that are very low cost, teach the people in developing countries what parts to buy, how to build them, in such a way that you can have the access to this equipment to help smallholder agricultures. In 2002, we built our first hot air balloon and did the research to accommodate platforms with cameras to take pictures over our fields here in Lima, Peru. Then we moved to model planes. They work very nicely here in our experimental station. But then to move that technology to the field is impossible because you need runways, and they are not available everywhere. Then the multi-rotors came along, and then we started to work on multi-rotors. Working with multi-rotors or fixed wings allow us to fly under the clouds, so you get rid of the cloud problem. By flying at low altitude, between 100 and 150 meters above the ground, you get very high resolutions. I mean, you get pictures with a resolution in the millimeters or centimeters, depending on the cameras. They are very low cost. And with the appropriate software, you can use that information to serve the purpose of smallholder agriculture. The heart of remote sensing is the quality of the sensors that you have, because those determine what you're registering and the quality of that information. You can find different type of sensors costing hundreds of thousands of dollars, of very, very good quality. But those are not affordable for developing countries, especially for those in helping the smallholders agriculture. We are developing the, the sensors that are needed for agricultures in developing countries. That means sensors with high quality and low cost. To do that, we have access to the state-of-the-art technology of costly sensors, and then assembling our own sensors with parts that you can buy in the markets. For developing countries, and especially for smallholders agriculture, we need to have sensors that are of good quality but are very low cost. And this is the task that SIP is addressing. To transform data into information, you need to process them. Processing images need complex algorithms. It is difficult for people with low budgets to buy software that would do that. That is why SIP is developing the software scientists, extension agents, AGOs, and farmers in developing countries could use, because they are free of charge. You can download those from our webpage and use them. You can modify them and grow with us in the development of solutions to process images. The software is needed to make maps of the images taken by the drones. To do that, you first put them together into what we call mosaics. To do that, we stitch them together and then process those images to extract the potential yields in the field. What is the variation in space? If you have spots with low productivity, you can go to the field and to those spots and then find out if you have water problems, fertility problems, pests or diseases problems, and then make the corrections. Extension agents, farmers, NGOs could use this product to make better management of their landscape and their farms, and then enhance productivity. Knowledge in itself is power. We are contributing with the ARSIS systems, the Agricultural Remote Sensing Information System, to generate the information needed for precision agriculture in developing countries. With the drones and the sensors and the software we're developing, we are sure that if developing countries use this information, the smallholder farmers that produce 90% of the food in the world can really increase their productivity and make better life for themselves. Everything that SIP and the CGIAR do are open source and free for everyone. You can come to our webpage, download everything that we have there, and use it.